the new book was inspired by a disconnect, and it really had to do with trying to come to grips with whether or not ChatGPT understands language. There was a big argument that was raging already, back and when it first came out 2 years ago amongst academics, and they couldn't agree. I mean, these are people who spent their whole lives on cognitive science and linguistics and AI, and it's still raging. It's still a very, very hot topic in the field of machine learning right now. The extent to which ChatGPT is intelligent.
In today's fast-paced world, ensuring your AI systems are not only compliant, but also accurate and robust is key. How can you achieve reliable AI outcomes while managing risks effectively? If you're facing challenges with AI risk management, having a solution that ensures accuracy and robustness is invaluable. Citrusx AI offers cutting-edge technology for you to detect and mitigate vulnerabilities, biases, and errors while ensuring accuracy, robustness, and compliance. Their solution is the only one that offers observability capabilities while helping you meet regulatory requirements. Citrusx.ai ensures your AI models are not just performing well, but navigating risk safely. Elevate your AI model management with Citrusx. Visit email.citrusx.ai/IonAI to book your free demo today and learn more about how their solution can benefit you. That's email .citrusx, CITRUSX.ai/IonAI, IonAI, all run together, EYEONAI, to book your free demo today. Can you start, Terry? I know who you are. A lot of people know who you are. I saw you referenced in the Jeff Hinton announcement, which, of course, I would like you to have been included. But because Boltzmann machines played such a critical role in that development, so can you give listeners that are not familiar, have not seen our past episodes, a brief introduction of your work and your work at the NeurIPS Foundation, and then about your new book, which is what I really wanted to talk about.
Well, yes, Craig, my background is in physics, PhD, theoretical physics from Princeton. And at that point, I realized that physics had reached these such high levels that in order to make progress, you had to have an accelerator that was miles across or set up a satellite. And so I was very attracted to the brain because it was just as mysterious as the universe, but it was something you could actually study, in the lab. And I met Jeff at a small conference here, actually in San Diego, that he organized on associative memory back in '79. That was quite a while ago. And we just hit it off. I mean, it was clear that we both had the same goals, to try to understand, how the brain could possibly solve these difficult problems. Number one. Number two, what was, computational capabilities of very large scale network models, and it was in its infancy back then. And so that John Hoffield was my thesis advisor, and we ended up generalizing his model by adding noise to it, of all things, to heat it up. It's a physics model, spin glass model, and by heating it up, we were able to find not just local solutions, but also a global minima. And also, what popped out of that, and this is still amazing, one of the most beautiful things that I've ever done, which is a learning algorithm when you come to equilibrium. And so it was a big physics project because it took advantage of everything that we know about statistical mechanics. And Boltzmann, of course, was the father of statistical mechanics, and so that broke the logjam. That led to backprop, which Jeff and Dave Romahart introduced shortly thereafter, and the rest is history.
Yeah.
So Jeff, he spent the next 20 years figuring out how to use the Boltzmann machine, and then eventually backprop to solve these difficult problems. ImageNet back in, I think it was 2012 or 2013, at NeurIPS really started the deep learning revolution
Yeah.
with object recognition in images. But my career path went off toward neuroscience. I did a postdoc at Harvard Neurobiology, and then eventually wound up here at La Jolla at the Salk Institute. I also have a faculty position at UC San Diego where I teach, and I have an Institute for No Computation. So I've had this dual role, and by the way, very early on, I became the president of the Neural Information Processing Systems Foundation.
Right.
Neural networks was very hot back in the 80s. It was very interesting and intriguing. People from many different areas of physics and engineering would show up at these meetings. Around 500-600 people would show up. And that grew gradually over years, and we didn't have enough computing power really to scale things up. But eventually, that happened. In this century, we didn't know how well they would do, and it's way beyond my expectations of what I expected back then.
Yeah, and so and I've read Deep Learning Revolution, and for listeners who want a great history of that whole development, it's a wonderful book that came out, I think, 5 years ago. I don't remember.
Yeah, no, it was 2018. It was the origin story of
Right.
modern AI. Yeah.
Yeah. And so now you've got, fast forward, uh, Transformers appeared, and together with back propagation and some other things, it's created this entirely new field of generative AI, the most public facing of which is the ChatGPT models. Uh, and you're writing about this, sort of looking at what that means and what to expect going forward. So, can you talk about the new book?
Yes, the new book was inspired by a disconnect, and it really had to do with trying to come to grips with whether or not ChatGPT understands language. Does it understand understanding?
Yeah,
And there was a big argument that was raging already, back and this when it first came out 2 years ago amongst academics. They couldn't agree. I mean, these are people who spent their whole lives on cognitive science and linguistics and AI, and it's still raging, and it's still a very uh, hot topic in the field of machine learning right now. The extent to which ChatGPT is intelligent. I mean,
yeah,
and so I looked into it and I started trying to understand uh, where the disagreement came from, and I made a bunch of observations, and this is something that had to do with how people were using it, and it occurred to me that look, ChatGPT is trained on thousands and thousands of books and enormous amount of articles all over, we're talking about novels, textbooks, and it can adopt any persona because it has all of that stored away somewhere. And when you talk to it, it has to pick a persona.
yeah,
And you can ask it. You can say, I can. You can tell it, I want you to be a poet,
right,
or I want you to be a computer scientist. You can set it up. That's the prompt. And depending on how you prompt, and especially how you you set it up in terms of what it is that you wanted to, how you wanted to do it, what you wanted to do, and what persona it should have. That determines the responses you're going to get, the quality of the responses, the kinds of things. And uh, and and once I saw that, I realized that this is really a mirror. It's like looking into a mirror, and it is looking at you, and it is trying to respond as best it can to whatever kind of prompts you're giving it. And then once I realized that, I realized that we're it's completely wrong to think of it, well, the way that we are. We're trying to judge it, is it human or not? It's obviously not human.
Yeah.
It's like an alien that suddenly arrived on Earth and is talking to us, but it's not. It's coming from some other world, right? And so but what it is revealed is something that I think is very deep uh, 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 revelation about the poverty of the words that we're using to describe cognitive function. All these words come from 19th century psychology or even earlier, and they're ambiguous. They have multiple meanings. They're not as well tied down scientifically as words in physics, like matter, mass, energy. All of this is something that is we're in a kind of a pre-Copernican era here in AI. And so we don't we probe words like intelligence. We don't really know what those, how to apply it.
Yeah.
There's a huge raging battle in biology, about whether other species are what kind of intelligence they have, or are they conscious. And it's books written about this, and I think that we're now we've entered an era now where we can begin to maybe understand these concepts in a more deep mathematical way, because we can create these artifacts that have some of the properties of what we consider language and understanding. And if we can understand them first, mathematically, maybe we'll be able to understand our animal brains.
Yeah. Well, and in that language, in the fuzzy language used to describe this stuff, understanding is one of the first that creates confusion. And I remember thinking about that when uh, Alpha Zero, I think that was the model at the time, uh, beat Lee Sedol in that Go game in Seoul in whenever it was, I've forgotten, 2016 or something. AlphaGo made this uh, completely unorthodox move 37. It placed a stone up in an empty part of the board, and as I recall, Isidol got up and walked away from the table for a little while to think about it, and no one understood it. And then as the game played out, it was that move that ultimately turned the tide and beat Lee Sedol. And I remember thinking and saying to people, "Wow, that AI system understood. It understood. I mean, whatever understands means. It wasn't simply running down, some sort of a search tree, Monte Carlo search or something. Uh, it looks like it understood it. So, how do you work with that word understanding?
Okay, so first, a couple of footnotes to your observation. First, um, this was a sign that, in addition to being able to talk, that these large language models are actually creative.
Yeah,
And we've always thought that was the highest level of human cognition, right? And by the way, hallucinations, which people say, oh, you can't trust it, it's a form of creativity.
Yeah.
it's a it's the flip side of creativity. When it's hallucinating, it actually doesn't just make things up. It's very plausible things, right? Things that could exist or could happen, you know, but they never did. And so by the way, this is also true in humans, right? Humans also confabulate.
Yeah.
It's a different word in medicine, but it's the same thing. Is that humans, for under some conditions, um, will make up things just like that, right? And
Yeah.
it's like the brain is not able to actually judge themselves. I mean, of these people who have like Korsakoff syndrome, they can't themselves judge what's right, what's true. They're just saying things
Okay.
that the brain thinks is true. Their brains. Okay, the other footnote is that what you just described was already apparent back in the 1980s, early 90s. Jerry Tesaro, who I worked with actually on applying these learning algorithms to backgammon, right? It's a simpler game, but it's actually a very popular game. And what makes it actually difficult, more difficult in some ways, is that it's probabilistic. You throw a dice, right? So it's not like chess where you can go, 20 moves ahead, and it's deterministic in terms of knowing where pieces are and where they're going to be. But but nonetheless, it turns out he applied the very same. The really the secret to AlphaGo was to have the game play itself,
Right.
right? And because it's playing itself, it basically can go off in new directions that are unanchored from the way human beings play the game. And it's really interesting. Back then, I mean, the computers are really puny compared to what we have today, but nonetheless, he was able to reach a level of play that some of the experts said were at the championship level, and in some cases was making decisions at critical points in the game that were even better than the decisions that humans were making. In other words, it was being creative with new moves that no human had ever made before. So it was already apparent back then. Okay, and if I could, this is a little bit immodest, but uh, most of the networks back in the 80s were toy
Yeah.
problems that we just created because the networks are too small to really solve any real world problem. One exception to that, maybe there were a few, okay, but the one that I was involved in was NetTalk.
Yeah. I remember. Yeah.
And that was a problem in linguistics of how you pronounce letters in words, phonology. And it's a very difficult problem in English, especially because it's so ambiguous. So the single letter can be pronounced in some cases, 5, 10 different ways. English has gotten influences from many other languages, and it's very complicated how those mesh. But and linguists, who were using rule-based approaches back then, came up with rules, but there are exceptions to the rules, and then there are within the exceptions, like for French words, there were rules for the French exceptions, and it was rules all the way down, and you have books with 300 pages of rules and exceptions. Well, we trained up. This is a summer research project. It was a graduate student from Princeton, Charlie Rosenberg, who showed up and I didn't know anything about linguistics, but he did. He worked with George Miller, and so we took on that project. And by the end of the summer, I'll tell you, it was pronouncing words understandably. We played it through a deck talk, which actually you could hear it, and it was amazing that you can get such a tiny network, 20,000 connections, 200 units, and it absorbed not just the regularities but also the exceptions in English pronunciation. And this was it was an amazing demonstration because I could play this tape for people. At the beginning, it babbled, and a little bit later, it started doing small words, and then later at the end, it just was able to generalize so new text, and it did it beautifully. Now that, in retrospect, was an indication that the networks love language,
Hmm.
right? And that's clearly what ChatGPT is telling us. It's like unbelievable how well it can do, and it's actually still tiny compared to the brain, right? Even with a trillion weights. The brain has 1,000,000,000,000. It's the thousands of trillion. So that's in some ways, ChatGPT is already super intelligent because it's absorbed much more knowledge than any human brain could, right?
Yeah. Yeah, and a couple of thoughts on that. One is on the hallucinations. I often tell people that, as this is what you're saying, that people hallucinate too. If you ask me what color shirt I was wearing at my fifth birthday party, which I can remember very well, I'll say blue, and I can see that image in my head. But if I flip back through family photos, I see, oh, I was wearing an orange shirt. Uh, it's, but you are so convinced that image is so clear in your head, and
Right.
that's a form of hallucination. And so, this word understand, I go back and forth. I mean, I tell people who are not involved in AI and are totally amazed by the large language models that these things, it's just predicting the next token in a series based on the probability in its training data. And if you hit a spot where the training data is relatively sparse, it'll pick a probability, and that will not be what you consider as right. So when it is picking the probabilities that we consider right, we consider that understanding, and it sort of begs the question of what human understanding is. If indeed we're a network of weights that we've accumulated throughout our lifetime, uh, are we just uh, coming up with probably, this is the stochastic parrot argument, and I mentioned this to Jeff last time I talked to him, or I haven't talked to him for well over a year. He's suddenly unavailable for my level of people, but and he said no, they understand, and we didn't get into a debate about what understand means. So anyway, how do you deal with that term understanding, and do humans understand in the same way that these massive models understand, in that we're just our
Well,
chain of thought is based on
you
probability?
don't have to go to the Chat GDP. You know, different people understand things differently.
Yeah,
you know, it's not one thing that it's not one way to there's no one way to understand something. There are many different levels of understanding. A physicist understands
yeah,
the composition of things much better than a person who just picks things up and uses them. But a carpenter understands wood perhaps better than a physicist because he knows about the grain and he knows about how to cut it and different types of wood and so forth. You know, and so there's many different ways to understand something. So that's number one. Number two, uh, the uh, the I think the Jeff's comment, and I've talked to him about this. In fact, recently I've talked to him almost every day. I mean, he's really he's transformed into a completely different stage of his life now, right? I mean, once you get the
sure.
Nobel Prize, it's a different you're in a different society now puts you on a pedestal. But uh, his argument is the following: that uh, in order to be able to predict the next word, you have to have a pretty good internal model of what that sentence is all about, right? and that means semantics. It's you have to. It's more than just predicting whether it's a verb or a noun. It's how that new word that you're predicting fits into the rest of the words, right? It has to, the context of that word, and the internal model. If you keep training it and it gets better and better and better, the internal model is going to get better and better and better, right?
Mhm.
And at some point, it becomes good enough so that it actually comes up with the appropriate, reasonable words for the meaning of that sentence, right? And that's a form of understanding. Uh, you might say that it's superficial understanding. What's the level of depth? How do you compare it with uh, a human in the same situation? Um, it depends on the human. It depends on what the also, as you say, the database that was used to train it. Depends on a lot of factors. But I think that Jeff is right that the internal model, and we actually have some evidence for this, that the internal model is integrating information from many different sources. First of all, from the text that it's being trained on, but also from the order of the words. That's syntax. That's something that linguists really put a lot of
Mhm.
effort into in the last century. Understanding that was important. But in addition, it turns out what was ignored in the last century was that language is all about meaning, and that is syntax. I'm sorry, it was a Freudian slip. It's all about semantics,
Yeah.
and semantics is the purpose of language. Is we talk to each other so that we can understand each other, the meaning of what I'm trying to communicate with you, and back and forth. Right? That's at a semantic level that we're trying to exchange thoughts. Right? The order of the words, it helps with getting the semantics across, but it's not, doesn't contain the meaning itself. It's actually, of all things, a lot of the meaning is coming across not just from the words, but how you say the words, what you emphasize. It also depends on facial expressions. If you're talking to somebody and you see them, you'll have a different message, a different meaning than if you are just listening to somebody on a recording, right? It's language is incredibly, has many, many, many dimensions and many, many ways that we take information in and try to incorporate it. Our brain is doing a lot of that subconsciously, by the way. We're not even aware of it. It just happens.
Yeah. The There was a wonderful book probably 20 years ago by a New York Times writer named James Gleick called The Information. I don't know if you read it, but and he talks there about language and writing and thought. And his uh, premise, although not alone, he drew on a lot of people, but is that speech disappears. It goes out, and as soon as the sound waves have passed you, it's over. And it wasn't until writing developed that people could start analyzing, uh, that people really started thinking, that thinking analytically, that they could say something, stick it out there, look at it, and analyze it. And that felt pretty deep to me. What are your thoughts about how this not only speech, but how the written language, which is what these large language models are trained on. They're not trained on people just talking. It's written language and huge volumes of written language. How that relates to thought and whether and this whole idea of understanding, whether it's it's the analytic exercise on written language that creates understanding. Or you know what I'm thinking about? Maybe not. I mean, you.
Okay, well, I haven't read that book, but I agree with him. In fact, when people say language, they usually mean spoken languages as
Right.
being the breakthrough that the humans evolved this ability to talk to each other. But I can, it's pretty clear that there's all kinds of limitations. As you say, the spoken words basically disappear very rapidly, uh, and your memory of the words will mutate. As you know, there's a lot of studies have been done. Where the story changes, the details change if it's retold. Um, and also, language can be used for controlling other people. Rhetoric, if you're good at tapping into emotions, if you're good at coming up with arguments that sound plausible, you can get a lot of people to do things for you, right?
Yeah.
And the bigger your bullhorn, the more the people. And
Yeah.
unfortunately, what happened is that technology got better and better, right? You can have more and more people come and listen to you, or you can the radio or the television. You get the words are can be spread throughout millions of whole nations, right? Uh, now what you're now, but I for me the real turning point was not the evolution of spoken language, but the written version. That's an
Yeah.
invention, by the way. That's not
Yeah.
something that came from nature. We're actually we adapted our visual system in order to be able to do that. Um, of course, the visual system evolved too. But the point is that we have to go to school to learn how to read. It's many years. I mean, it's something we're over practiced on. If you went to school for I've been going to school my whole life, reading scientific papers all the time and trying to understand written words. The jargon vocabularies. I mean, it's unbelievable what we now have right out there, and it's really it allowed us to do two things. First of all, to accumulate knowledge. Number two, to correct knowledge.
Yeah.
That means you can go back and here's what Mr. X said about Y. Well, I'm going to investigate this Y, and I have found that Mr. X was wrong, and here's why. And that could be at a scientific level where you do an experiment, or it could just be at a conceptual level, or in other words, you can build on what was there before. Whereas if all you have is the written word, basically the most you could do is to have somebody who's really good at memorizing stuff. you know, the bards, the people who were
Right.
told the stories of the past. That was the way history was transmitted from one generation to the next. And that's very limited. The bandwidth there is very limited. But now when you can write, and now, books was a big advance because now you could have multiple copies of the same thing instead of, stone tools, for hieroglyphics or whatever. Now you could disseminate it amongst at least the people who could read, which is a very small fraction back then, but now many more people. And then eventually, science
Yeah.
took that to another level, which is that not only are you transmitting words and thoughts, but you're transmitting observations, experiments, new insights that other can be replicated. Other people can do the experiments. Other people can build the same thing.
Yeah. Uh,
And go
uh,
ahead.
well, on understanding, coming back to understanding, uh, your feeling is uh, that these large models do at some level understand, and that's with using this fuzzy word understand. What's the limit of that? Because understanding leads to self-awareness, and self-awareness leads to sentience. Uh, yeah, what's your feeling about that spectrum and where uh, these models are on it?
Okay, so that's a big part of my book. I
Hmm.
have several chapters specifically trying to understand how, what's missing. Okay, so the model that is used in ChatGPT is primarily a model of the cerebral cortex.
Yeah.
You know, the big knowledge base that we have. Um, but you know, it's only one of about 100 different parts of the brain that are absolutely essential for its function, right? So I'll tell you, most of what's in the brain is missing from ChatGPT.
Yeah.
And I'll just give you, I made a list in the book, but I'll give you the sort of the top hits. Okay, number one, ChatGPT does not have a goal. Now,
Yeah.
nature put goals into us, which is survival, reproduction. You know, we got to eat. You know, we have to sleep, and there's all sorts of things that humans, uh, you know, they have. They're very social creatures, so you know we need to be in a social group in order for the brain to flourish, right? And you know that comes from evolution. Uh, so that's number one. We you know they were trained without any real goals, or for that matter, any instruction about what's good and what's bad. You know, children when they grow up, right? They're given all kinds of feedback by their parents, by their peers, by their teachers. You know, don't say that. You know, that's bad. You shouldn't do that, right? Or it's dangerous. And all ChatGPT never gets any of that feedback. Never, it's never told what's good or what's bad. It's never told, you know, what's dangerous. And so that's reinforcement learning. It's another part of the brain, the basal ganglia, which interestingly was used in AlphaGo. AlphaGo had a value function,
Right.
which is what the basal ganglia creates a value for future rewards. You know what you should do next if you want to get an award. Reward. A reward could be anything. You know, it could be some tasty morsel, or it could be a university degree, or it could be becoming president. Right? You know, if you think that that's something you cherish. But you know the reality the reality is that uh, it, you know ChatGPT only has kind of a superficial set of goals, which was you know to predict the next word. That was very superficial, but it's very important. By the way, the same humans have a very likely are using the same kind of algorithm. We know it's true for the value function. It's a reward prediction error. You
Yeah.
predict the reward you're going to get, you compare it to what you do get, and from that difference you change the weights to in order to be able to make a better decision the next time you get that input. Okay, so that's a very general principle. But now here's something that is even talking now with regard to sentience. Here's something that is a showstopper, literally. Okay, so you're talking to ChatGPT and it's responding. It keeps responding word after word, and then at the end it finishes and it thanks you, or it says, "I hope this is okay." It's very polite, right? And then it stops. What happens to the network when it stops? Nothing.
Yeah.
Nothing is going on in that network. The only time that anything happens is when you give it a question or you give it a prompt, okay, right? That means that there's nothing going on there. It's completely empty. It doesn't have any self-generating activity, right? So I think it's literally a no-brainer about sentience. It's not sentient in any sense of the way that we are, because you put us in a room, no sensory inputs. What's going on? Well, you're thinking away, right? You're thinking about what you're going to do later in the day. You may think that you're hungry. You may want to think about going to the supermarket. In other words, you're planning all the time. You're coming up with responses. You're thinking about, what your goals are and what how to accomplish that. Or maybe you're just enjoying a movie and thinking about the movie. You know, but the idea though is that we have a constant flow of thoughts in the absence of any direct input. Obviously, you may be responding to something you heard yesterday, and that's been circulating because you've been a new way, a new idea, or maybe you were I don't know. I mean, actually, unfortunately, a lot of these are emotional things that you think about. You get unhappy, you get sad, you feel that you've been maligned, and that'll continue to circulate. In fact, sometimes that leads to mental disorders, right? When you have people who are anxious and so forth. So in any case, there's the many uh, lessons to be learned from the way that nature has gone about creating autonomy. Something. All animals have to survive. All animals are autonomous to some degree, and insects. I mean, it's not just animals. Insects, plants. All of nature is autonomous in terms of self-regulating and self-creating and so forth. And of course, they interact with each other, and that's part of the complexity of nature. But right now, these chat GDP, they're trying to make them into agents, but they're not. They're just not. They don't have the same agency that we have.
Yeah. Well, let's talk about agents, though, because that is the next frontier. And there are uh, now agents that can perform mental tasks that were previously performed by humans. You give the agent a goal, and it'll perform that task continuously. And now you can chain agents together where each one performs a discrete task and hands the output off to another who performs another task. Where do you see that going? Because it seems that combined with the quote unquote understanding of large models, that having goals and having agents collaborate with one another could lead to something unexpected.
It's a interesting direction, and one of the things that we have to be, you know, prepared for is that nobody can predict what will happen, right?
Yeah.
I mean, in other words, it's a surprise, a surprise. I mean, ChatGPT was a huge surprise, right? All these things, the language translation was a big surprise, and I'm sure that's going to continue. So who knows? But one thing to keep in mind, and this is kind of a more mathematical argument, is that two chat GDPs talking to each other is just one giant GPT.
Yeah.
It's no different.
Yeah.
It's maybe it's you've externalized some of the internal stuff that's going on, but it's basically the same. It might have additional capabilities. I'm not saying that it doesn't, but what I'm saying though is that it's really there's nothing that is special, in terms of the uh, it's they're not human agents, right? They're not behaving like human agents.
Yeah.
It's like I say, we're there are other parts of the brain, there are other things that make us agents. And, maybe there's, again, agency is one of those words that has multiple meanings, that has a spectrum, and that maybe, you know there is a little bit of agency there that can be enhanced, amplified somehow, but it's not. It's pretty far along that spectrum. In terms of where we are and where other species are. But
Yeah.
maybe, again, this is something that, I started by asking you if you could have predicted where the internet was going. This is an even more uh, difficult problem to try to imagine. And it's people worry about superintelligence and taking over, existential threats and so forth. I don't think we actually know what the real threat is going to be. I think
Yeah.
that there's something unintended consequence that's going to happen somewhere up the road, and it's going to be unexpected, and who knows what it's going to be.
Yeah. In the book, you talk about nature inspired directions for developing generative AI. What do you can you talk about what you mean by nature inspired? Is that are you talking about other functions in the brain, for example, or
Well, okay, so the right now these large language models are completely helpless by themselves,
yeah,
literally. They depend completely on us, moment by moment. They depend on us for the power to get them going. They depend on us to give them inputs, right? They depend on us for improving them and so forth. I mean, they're really cocooned
yeah,
in a very complex web of technology. And you go out in the simplest creature. There's a field mouse out there, right? I mean, they're by themselves. They're going and they're finding food and they're interacting with people in the tunnels and so forth. I mean, my God, they are so much more advanced than anything that we're building right now in AI. They're just like in a different world because they're uh, they're able to navigate the real complexities of the world, which are not words, but the physical world, the physics that is really that determines the properties of materials. That if it's digging a hole, it's got to figure out how to do that. If it's got to find food that is edible, that isn't going to kill them, they got to do this all, in order to survive. And the brain has figured out how to do that. That's why the brain has 100 other parts
yeah,
that help us and all species, including insects, how they could be able to navigate. And so here's a story. Um, when Jeff and I and others in the early days of neural networks in the 80s were trying to have come up with this alternative approach to AI, we were not taken seriously, right? We were the furry little mammals under the feet of the dinosaurs. But I was invited to give a distinguished lecture at MIT, and I was really thrilled. I mean, this is amazing. They're going to take me seriously. So I went there, and I was told that there's a tradition at the AI lab that the distinguished lecturer would have an opportunity at lunch to have a discussion with the faculty and students. I said, great. As we're going up the elevator, my host turned to me and said, Terry, and they hate what you do. Whoa. Okay. And I suddenly realized that it was, this is not what I thought it would be. And in fact, it's like walking into the lion's den, right? I mean, here I am. And the host turns to me and said, "Oh my, we've never had so many people turn out before, right?" It was like I was the main attraction here. And we'll give you 5 minutes to start the discussion. Wow. Okay. So what do you do? Literally, I had less than 5 minutes to actually come up with a plan. And so I looked at the table with the sandwiches on it, and I saw a fly circling. And I said to the audience, I said, "You see that fly? Okay. Well, what's amazing, it can fly, it can find food, it could reproduce. And it's doing that with 100,000 neurons, right? You have a supercomputer in a basement, Cray XMP, costs you $100 million. It can't fly. it can't see, and it's not going to reproduce.
Yeah.
You know, what's wrong with this picture? Dead silence.
Yeah. Uh,
Okay, but let me tell you how it ended. This is really even more interesting. So one of the senior faculty said, "Well, we haven't written the vision program yet." And I said, "Well, look, DARPA has put billions of dollars into computer vision, and the program has not yet been written. There's no indication that it's growing combinatorically, and it's not converging. Okay, good luck with that." And then another faculty said, "Well, but we have a guarantee from Turing, that these digital computers can do universal computation. So eventually we'll find the program." And I said, "Well, wait a second now. Okay, it's not just finding the program, but how fast can you get the answer?"
yeah.
And because of that determines whether you're going to be eaten or not, right? And you have to make your decision quickly, and that's how nature evolved in order to be able to make quick decisions. And finally, someone at the back was a student said the difference between the fly and the supercomputer downstairs is that the digital computer is capable of running any program, not very efficiently, whereas the fly brain can only run that program. That's it's running. It's doing one thing and does it very well. And I said, "You're absolutely right. That's exactly the difference. It's nature has done something special purpose, and digital computers are more general. You can simulate lots of different things, but the difference is that just knowing with the architecture of the digital computer, you'll have no concept of how to solve any problem because it's so general. Whereas you go into the fly brain, the algorithm is literally the hardware. It is the structure of the connections between the units. By reverse engineering the fly brain, we'll figure out how to do vision. We'll figure out how to make decisions, how other animals do that. And at that point, that was the end of the discussion. So this is this was kind of a harbinger of a completely new way of looking at computation that apparently these super smart people at MIT had never even thought about. This it was literally it was a student up there who actually understood what the difference was.
Interesting. So, and we're coming up to an hour. I don't want to take too much of your time, but uh, what's the sort of forward-looking conclusion in the book? And you can tell, Terry, and I apologize, I haven't read the book yet. I will read it by the next time I see you.
Right.
But what is the forward-looking conclusion
So
about where we are? Yeah.
first of all, the book is written for the general public. There are some parts in it that are technical, but I asked ChatGPT to summarize them for me. And I've gotten feedback from reviewers saying that they were really helpful. So there's something in it for everybody. But there are a couple of messages that I wanted to get across. Uh, a question that I'm often asked is, "Will I lose my job?" I mean, and the press is just churning out articles about how people are going to be obsolete. Super intelligence taking. I mean, it's crazy out there right now. It's people who don't really understand what's going on inside. I'm an insider, so I have a little bit of an insight here. And so here's my response, or at least my advice to people out there who are worried about. And there are a lot of people worried about their jobs, right?
Sure.
I mean, they should be, given what they've read. You're not going to lose your job, but your job is going to change.
Mhm.
And it's going to change because you're going to be given new tools to use. And here's the analogy. Okay, suppose that your job is to dig ditches with your hands, right? Like a mouse. it's a hard job. I mean, the soil is not necessarily easy to get out, and sometimes it's rocky. And oh my God, what a horrible job to have, right? But if you have to, you can do it, right? And there's a lot of work that people do that's a lot like that, although maybe not as dirty, but it's still routine stuff that has to be done. Now, but somebody invents the shovel, a new technology. So so you pick up the shovel, and you're not quite sure what end to use yet, and you play with it, but eventually you realize that, oh, I can dig faster, I can dig deeper. It's much more efficient. It's a much better tool, but I have to learn how to use it first before I become good at it, so that it's actually better than you're pretty good at doing the raw digging, and so now you have better technology. Same thing's going to happen. People are going to start using ChatGPT. It's going to make a lot of their routine stuff easier, faster. It's not going to replace them. They're still going to be there. They're the ones who are using the tool. It's not ChatGPT using them, right? So that's one thing. And the second thing, and this is something that was also a kind of a message for my first book, which is that AI is going to make you smarter, literally,
Yeah.
literally, and it's going to make you smarter because you're going to have access to much more knowledge, and you're going to be, exposed to things that ChatGPT is gathering for you. I mean, this is kind of Google search on steroids now, where you're
Right.
talking about, coming up with answers to English questions, not to keywords, right? And that's already happening, right? That's already happening. But it turns out, again, you have to learn how to use the tool. You have to learn how to prompt. I have a whole chapter on power of the prompt. And you have to actually interact with it in a different way. You can't just, it's not like a typewriter.
Yeah.
Uh, actually, it's really interesting. The typewriter, if you look at it, right, the typewriter really is going to be obsolete in a few years because of the fact we can talk now to digital computers. We don't have to use keyboards. I'm sure that they're not going to go away immediately, but eventually there will be much better ways of interacting. Even okay, one of my former postdocs has a company now called SoftEye, and he thinks that cell phones are going to become obsolete pretty soon.
Hmm.
They're going to be replaced by AI.
Yeah.
Okay, I mean, he might be right, but he has a startup company, and he's negotiating with big companies. But the point is that, okay, the internet has already done that for me, right? For all practical purposes, I've become omniscient. I can search the world's database for anything, and now that I can use ChatGPT, I can do that even more efficiently, right?
Yeah.
So this is, and by the way, it's going right into my brain. My brain is learning things, right? It's always absorbing things, and it's doing it now at a much higher rate than it used to. And in fact, we have, humans can learn, uh, for your entire life, lifelong learning. It's something that, again, okay, this is a good example. You said, what's wrong with ChatGPT? Well, once it's been trained, that's it. It's not going to learn anything new. You turn it off, and it's the old same ChatGPT. It hasn't learned anything from you. Right, so that's another thing that we've got to change if we want it to be an agent that's going to be able to absorb information that we give it and then use it in the future.
In today's fast paced world, ensuring your AI systems are not only compliant, but also accurate and robust is key. How can you achieve reliable AI outcomes while managing risks effectively? If you're facing challenges with AI risk management, having a solution that ensures accuracy in robustness is invaluable. Citrusx AI offers cutting edge technology for you to detect and mitigate vulnerabilities, biases, and errors while ensuring accuracy, robustness, and compliance. Their solution is the only one that offers observability capabilities while helping you meet regulatory requirements. Citrusx.ai ensures your AI models are not just performing well, but navigating risk safely. Elevate your AI model management with Citrusx. Visit email.citrusx.ai/ionai to book your free demo today and learn more about how their solution can benefit you. That's email dot citrusx citrusx.ai/ionai ionai all run together EYEONAI to book your free demo today.